Hello everyone, welcome back to another episode, and in this video I will explain how genetic algorithm works, how you can optimize your own objective function using the genetic algorithm. And if you are not familiar with the MATLAB programming or you are new to MATLAB programs, I already have made a video on basics. So that video you can see on the top right in the I button. So that video is a must watch. So first watch that video and then get back to this video. And recently we have created a plan. 2 days ago I have created an explanatory video on particle swarm optimization. You may check at the I button, and in upcoming days we have a plan to explain the artificial bee colony optimization, ant colony optimization, DA, whales, and many more optimization algorithms will be explained. So just like the video and share the video. So without any further ado, let's get started. So this is the code which is actually taken from the RPs, and this is a educational purpose video, explanatory video. So you have to open the GA file. So this is the main file, and we have different files. First one is the tournament selection. Here in this program we have three kind of selections. Let me click on run. So here it's asking for different kind of selection: roulette wheel selection and tournament selection, random. I will brief that in a while, but we can choose any kind of selection method as per own choice. There is a little bit difference, but that's not much. And then there is a sphere file. Let me open that, and in sphere file we have our objective function which we have to minimize. This is the selection, and there is a mutation, and there is a crossover operators. So these operators help us to create another offsprings. So basically in genetic algorithms we have some genes, or we have some initial population. We can call it as a parents create our first when we create our first numbers, and then based on the finest numbers we have to create the offsprings. So where the crossover and mutation operators help us to achieve that. So I will explain that in a while in more detail. So let me get back to the genetic algorithm. So this is the ga.m file. So here cost function is assigned, or this function is initialized here. So this cost function is actually sphere. So let me left click here to start a debugger. How debugger works I already explained in the MATLAB basic video, so which I already have. I will put the link in the description too. So I just left click here and I start in debugger, and here we want to consider 10 decision variables, or you can say for the convenience we want to consider 10 numbers. So 10 numbers means we have a variable x here. So this variable x have 10 numbers. So if we have 5 decision variables, we have 5 numbers. So make sure when you have made a change, just make sure you have to save that. Let me remove this, clear my command window. So we have our decision variables 10, and here is the decision variable matrix size. So it will be 1 row and 10 columns. And then we have our minimum and maximum for that 10 numbers. So let me click on run. So when I click on run, the cost function is initialized, or you can see in workspace that our cost function is, let me open it. So our cost function is actually sphere. So whenever, let me select that, and here you can see there is a little green bar. You can see that our cost function is used in our MATLAB program 4 times. So our cost function is actually sphere file. So whenever we have a call to the cost function, we will be into the sphere file where we calculate our objective function. So this is the objective function. We have 10 numbers and we want to find the numbers, which 10 numbers give us the minimum of total. This is the formula. So we need 10 x numbers which we can get minimum, or which give us the minimum value of using this equation. So after that, here are some genetic algorithm parameters. Here is maximum iteration and number of population size. Here is the crossover percentage. Crossover percentage is a just like a operator. And here is the number of offsprings, also parents. So this is the number of the offsprings which we have to calculate. And here is the gamma extra range factor for crossover. So let me explain a little bit about the crossover. So crossover actually works on the principle of recombination. So that is actually the genetic operator which combines different material from two or more parent individuals to create one or more offspring. So for example, if we have 10 numbers, just say them the numbers. So we have these numbers, and every number have its fitness. So for example, it have 2 and it have 5, and this number have 7. Just assume that we have this x, and this is the second x, and this is the third x, and this is the fourth x, and we have different x, and each x have the 10 numbers, 1 2 3. It can be random numbers between minus 10 to plus 10. So we have 10 numbers, and each number have the individual fitness value. So based on the fitness value, crossover will help us to create another offsprings. So for example, if these are these x and all these 10x or more, which is actually 100 here. Why 100? Because our population is 100. So these 100x values are our parents right now, and based over the crossover or crossover recombination, we have our offsprings. So similarly, there is a mutation process, and mutation process works in such a way that it introduces small random changes in the individual's genes. You can say them the genes. So for example, if we have the these population, and in mutation we do a small random changes in them, so we can create our offsprings, and that small changes will be based on the fitness value. So if this have a 2 fitness value, and this have a 5, and this have a 7, and this one have 1.5, so based on their fitness value, we have to introduce small random changes in the mutation process. I will explain that in more detail in a while. So this is the mutation percentage and number of the mutants. And let me click here, and let me click on continue. So here you can see that we have NC is 70, and we have NM, which is 30. So we have 30 mutants, and we have number of the offsprings that are 70. So here there is a process for the selection. Let me click on step, and it will ask for the relative selection, autonomous selection, and random. These are basically the same, just there is a little difference between them, and that difference is related to their selection, as the name depicts. So in roulette selection, we have individuals from the current population, which will later which will serve as the parents. So the individual will be represent as the parents, and then that based on that parents, or parents fitness or individual fitness when it will be evaluated, and then based on the probability of selection we will assign another fitness. So the individual with the higher fitness have a large slice of that roulette wheel, so it works on just like the wheel. So based on the fitness, based on the individuals and their fitness, we have some portion of the this wheel, and based on that it will works on that, and it will create random numbers random numbers will be generated and selected based on their probabilities. So the next one is the tournament selection, and in tournament selection we have initially we have parents, and based on their fitness it's a little bit different from the routed wheel selections. And in tournament selections we have to choose the individuals in form of the pairs. So in form of pairs we have numbers, and that will work in the tournament selection. And in random selections we have to pick the random numbers from we have initially the parents, and based on the fitness of these parents we have to choose the offsprings based on the random selections. So let me close that in a while. Let me click on. So let me click on step, and here if we use routed wheel selections we have to put beta 8. These variables will be used later, and if we have selected the tournament size it will have to choose the 3. So let me click on step. Okay, so now we are using the routed wheel selection, and here there is a variable, and here is the initialization. So this is the initialization part, and these variables we have to use later for our individuals or parents initially, and this will be the position. In position we have the numbers, and in cost we have the output from the sphere or from our objective function. And let me click on step, and this is the rep mat. Why I am clicking on this step? So to click on this step means I want to execute each line every time, so I can tackle what exactly is going on inside the MATLAB program. So here we have empty individuals, and we have 100 populations. So this empty individual have the same thing. This have the two variables. So there is a variable inside another variable, and in empty individual we have position and cost, as you can see that. So right now we are going to create 100 variables in the pop variable. So let me click on step, and here you can see we have initialized the pop. Previously pop was, or population was not present here in the workspace. So here you can see that there is a different sign for that. Means that this is a single variable, and this means it have another variable inside it. So let me open that, and here you can see that we have 100 populations and 100 costs. So first population position means we need 10 numbers of x. Why 10 numbers? Because our decision variables is 10, so we need 10 numbers here, each number with minimum of -10 and maximum of 10, and that 10 numbers, or that 10 value of x, let me show you in a while. So let me click on step, and here we want to create unifriend. So unifriend is MATLAB just doc and put that unifriend. So unifriend is a built-in MATLAB command, and what actually to do, it returns an array of random numbers generated from the continuous uniform distribution. There are different ways to use that, and here you can see you can also explore these ones, or you may read about it. So what does is doing, it is going to, we have variable size, we have 10 numbers. So this is the minimum, so this is the minimum, and this is the maximum. So we need 10 numbers, and unifriend means that we will create 10 random numbers with minimum of this and maximum of this. So in let me click ran 5. Normally the random numbers are between 0 and 1. Okay, and here 5 rows 5 columns. You can even go with the rand and 2 rows and 1 column. So 2 rows and 1 column we have random numbers. These random numbers, this MATLAB command works for the random numbers between 0 and 1, but this unifriend will give us the choice or opportunity to create random numbers with our own minimum and maximum. So our minimum and maximum, which we have defined above, so based on that we have created the position. Let me click on step, and here you can see that we have in our position we have 10 numbers. So if our decision variables are 5, then there will be the 5 numbers. And now right now we have to put that numbers into our cost function or into our sphere file. So let me move into the sphere file. Let me click on step. So that 10 numbers, x numbers, are now into this objective function or formula, which we have to calculate. And now that numbers, as you can see that there is a different color of arrow, means it's not active. Let me click on step. Now it's active. And so the cost or the output which I get from this formula in case of z is now saved into the cost. So this loop will run for 100 populations, and all these columns and data will be filled out. Let me left click here and click on continue. Let me remove that. Okay, so we have here 100 numbers, and these 100 numbers you can see that these are the parents, and up to now this is our random selection, and based on each individual we have the fitness. Some have the worst and someone have the best. So now we have to choose which parent have the finest fitness, which are performing better. So now we have the costs, and inside the pop.cost. So let me open the pop, and the inside the pop we are we are now considering these costs inside the pop. So these are the 100 population and 100 costs. So we want to now there is not any variable as per this name, so it will be initialized now. So now costs is and we have make them 100 columns and 1 row, and now we have to sort that cost. Let me click on, and now click on the pop. So now let me open the pop, and in the pop we have just sorted all our data. So the parents, just in genetic algorithm we say them the parents. The parents with each fitness value is right in front of him, this one. So now we have to so population 1, so first population is actually the best solution right now, because we can see here this is the best right now. So now we have to create the best cost, and we are initializing another variable, and worst cost pop end. So this one is the last one. So worst cost, so this is the worst cost, and here we can see that this is the we just save this number, okay, not x, just this cost. And now we are into the main loop of the genetic algorithm. Meanwhile recently we are working on it and not getting enough likes on our videos, so please just make sure to hit the like button. So it's just a kind of motivation for our team to create such content. And here is the maximum iterations, which is considered here 1000. And right now we are into the roulette wheel selection. So if initially we have used the roulette wheel selection, now we will be into this section. So if the used rounded wheel selection, let me click on step, and here is the rounded wheel selection. We have the worst cost and we have the costs, and this is the beta. Let me select that, and let me, so this is beta for the rounded wheel selection. So this is the component for the and here is the exp, which is actually the built-in MATLAB command. So based on that, let me click on step. We have calculated the p, and this is the p, this is the number which we get here, and later on we will use this in our rounded wheel selection. Let me click on step, and now let me select that p, and here you can see that where this p is used here and in rounded wheel selection. So we have made based on the worst cost and the costs, variable cost and the worst cost, we have calculated the p, and that p will be get in to the rounded wheel selection method. So this is the rep mat, this is and empty individuals. We have position and cost and NC. This NC is actually for the offspring, or it's related to the parents, and this number is calculated based on the crossover. So now right now we are here and repmat POPC. Let me click on step. You may explore more about the repmat doc repmat, and this step array containing n copies of A in the row and column dimensions. So we have to create n copies. Now let me open the POPC. This is the POPC, and here you can see that we have different structs, and based on 35 because we have divided the NC by so let me open the first one. So inside that we have position and cost, and inside that we also have the position cost. So if I have one here, it means we have create only one column, and we have two, so we want to create two columns, and this is the content which we have. So prepmat is actually creating the multiple copies of a variable which we already have saved in our which is already available in the workspace. So this is the number of the copies, and this is the how many times we want to use it. So this is the loop for the key. Let me click on step, and now rounded wheel selection. So now we are in this file in the rounded wheel selection. So let me left click here, get back to the GA. Let me click on step, and now the P is the 100 numbers which we have created based on the best cost and the worst cost. So these are the 100 numbers, and using this rounded wheel selection method we have to find the we have to sort them a little. So R is the rand, C is the this is another you may explore that here. So this is returns the cumulative sum of A starting at the beginning of the first array dimension in A whose size does not equal to 1. So this is the description about that. So it will create. Let me click on step. Here you can see that we have variables which are used right here. Let me click on step. So we have created C based on the P. So we have our, here we have P, and there is some let me there is some modification in that, and that modification is done in the roulette wheel selection to find another numbers or another values of the X to get the better result. So let me click on step. So its I is actually find R is less than or equals to C. So this is the way of selection. So let me click on step. So we are now into out. Let me click on. So here is the I1. So in I1 we have a number 68. Similarly, we have I2 and we have 2. So based on it's actually let me click on step. We are now again into that, and this time it will have another random number. So based on that random number, we have to compare here this thing. So let me click on step. So let me click on step. So right now we have I1 and I2. So based on the random selection, we have I1 and I2. So if there is a tournament selection, or if use random selection, so this will be gone out and this will be for the tournament selection. So for this you have to open the tournament selection, and here you can tackle how it will works. So there's a small difference between that, but we have choose roulette wheel selection right here. So let me click on step. It will be ignored, and now based on the okay, and in our population, in that pop which we have this population, or the initial population which we have created, and each have its own fitness value. So we are just tackling that 68 and 25. So in the our population, so let me open that. So this is the population which we have sorted. So at this number of 68, so this is 68. So we have to copy that into P1. Let me click on step, and here is the P1. So in P1 we have the number and we have the cost, and in P2 we have the number and the cost. So right now at this point we have P1 dot position. So the P1 is actually this one. So we are just considering the 10 numbers, not cost. And P2 dot position means inside the P2 variable we have position. So we are just considering this position by using this, and then we have the gamma factor, VAR minimum, VAR maximum. We are putting that into the crossover. So now let me go into the crossover. Let me left click here. Where we were, okay. Let me click on step. So now we are here. You can see the same variables, same numbers are now into this. These are the 10 numbers, and these are also the 10 numbers. So based on the unifriend and all such stuff, we have in crossover we have to combine the numbers. So here we have two kind of numbers. X1 is a different number and X2 is a different number. So based on these numbers we have to combine them. So let me click on the continue. So you can see we have y1. So we have just x1 minus 3.6 8.2. So we have just combined them, these numbers. That is actually the crossover is about, which is about the recombination. So genetic operator which we have this is the genetic operator which will be combine genetic material from two or more parents individuals to create offspring. So we have parents, you can say x1 and x2, and we have combine them and we create another offspring which is y1 and y2, and it will be better. So let me click on step. So right now we have, and we have replaced them. So popc, let me see that in popc what is k here? K is 1. Okay, so we are going to update that popc variables which was not actually available right now. So we are updating that numbers, that offsprings into popc as a position. So when I click on step, so here in popc this function we have all these are empty, but this thing is not empty because we have recently update the data into it, and still cost is not. And now right now we have this number, this is the position, this is the right way position which we are putting that number. So this is the position, this is the 10 numbers of the x which we have recombine or modify a little bit, and now we are going to put that number into cost function. Based on that, we have the costs, and which will be saved right away into this. Let me click on continue, and now we have the costs. Let me click on end, and this loop will be just like this one. Here we have 35, because we divide 70 by 2, we have 35 numbers. So at the end of this loop we have all the data filled up. Alright, now you can see nothing here. Let me click on continue. I want to get out of the loop. Okay, I'm out of the loop, and here you can see that we have 244 and 295. So pop C and all the columns, and we are into the pop C. Let me click on step, and now we are into the pop M, which is the mutation. Right now the C is representing the crossover, and pop M is representing the mutation. And this is the genetic operator crossover, and it have different kind of selection. We have done selection using the roulette wheel, and it have the process to combine the parents and create individuals. And similarly in mutation we have a different process. Mutation, it works in form of the pairs. So definitely we will work on the initial. So here we are going to create rep mat, empty individuals, and 30. We have to create 30 individuals. We have to create 30 empty individuals. We create structs just like this one. This one we will create. Let me click on step, and let me open the pop M. So we have 30 position and costs. Let me click on step, and here again this is the n pop 100 and rand I. So there is a difference between the rand and rand I. Just explore that. So returns pseudo-random scalar integer between 1 and I max. Okay, and let me click on step, and let's see, the I is 83. So between 1 and 100 it creates a number. So then we have the P and pop, so we are choosing right now. So similarly you can take an idea that how this selection is going in the crossover, and now right now in the mutation process. And now in the mutation process we have the number that is at the P, which is actually at the 83. So we are considering the initial population and the number at 83. So we just consider that position, and we are just taking that number into our the mutation process. And here mutation process, let me left click here, click on this tab. So we get all the data, these 10 numbers, and mutation, minimum, maximum. And now we have to modify this x. So we have to modify this x with the y. Let me click on continue here. Y is this number, and y is this number. So this is the number which we have update, and now our parent is updated with the offspring. So x is the parent and y is the offspring. Let me click on step, and now we have to put that number here. This is the position is updated, and here cost will be updated easily. Let me click on step, and let me get out of this loop. Let me click on continue. Okay, and here we have initial population, we have the population using the crossover and mutation. Let me click on step. Okay, let me open the pop. Okay, inside the pop, so what we have to we have in our pop we have combined the initial and the numbers which we get from the crossover and from the mutation, and now we have to sort them out. We have sorted here. The MATLAB program is sorting here. Pop.cost, click on step, and now we have our costs. All costs are sorted, and here let's see the worst cost. So worst cost is again the 668. So here is the truncation. Let me click on step, and let me open the costs here. So we just make similarly we just consider 100 costs here as per our population. So best 100 numbers we have considered here, and best solution is right away at the first position. Best cost iteration. So the best solution is cost is saved into the best cost one. So that is best solution. Let me open the best solution. So best solution, this is the 10 numbers, best numbers, and this is the best possible cost. So I just so MATLAB code is just updating that to best cost. Let me click on step, and it's done. Now this is the end of the first iteration. So at the end of this iteration will display the result. So this is this display the result. So if we run this iteration for 1000 times, it will repeat the process, and at the end of each iteration it shows the best cost which we get from the selections and the genetic operators like crossover and mutation. So let me click on the continue, remove that. Let me remove that. So at the end of this we have get these numbers. So now we have to print the output in form of this figure. So here you can see that as our iteration progress, our costs are minimized. So our cost is minimized up to this function. And here you can see that this is the best cost, and if I want to see which 10 numbers are giving me the best cost possible, so here is the variable which is actually the best cost, and that is getting from the best solution. So let me open the best solution, and here is the best solution. We have the best solution right here, and this is the cost for it, and here you can see that 1.3683 minus 8. So this is the let me copy that and let me paste that. Okay, let me just okay, let me copy the 10 numbers and let me clear all the variables. I just cleared all the variables. Let me see and see. Yes, so I just saved that A, and let me open this, and I want to see that is A, and let me click on remove the semicolons. So you can see that these are the 10 numbers which give us the minimum of this possible. So if we increase the number of iterations, maybe it give us the better solution, but that will takes a lot more time, and That's I think so that's perfect. So this code is get from the yarpis, and I will put the link in the description. And hopefully you enjoy this video and learn some new things in this optimization algorithm. So please like the video and hit the subscribe button and share with your friends. Put any comment, and if you want to learn about any different optimization algorithm, you may write here in the comment section, and I will create another video on that. Thanks for watching.